Alright, so I gotta start off by saying you guys are absolutely slaughtering me in the comment section saying I talk too much. But I'll take it as constructive criticism. I mean, at the end of the day, I'll do what I want to do, but I'll take it. And you got to be able to learn, take some of that criticism, and maybe apply it a little bit. Because sometimes you don't listen to it, and it's more useful to just not give a fuck and just keep doing your own thing, because people will try to stop you. There are haters. That's a real thing. But in reality, it's just like you don't even need a consulting firm. Like you have haters are my consulting firm. So I guess if I'm hiring a consulting firm, then I'm gonna listen to what they say. But they're not necessarily haters. But like I'm making these videos for the viewers, so therefore the viewers complaining that I'm talking too much, and I'm already talking too much. Let's go. We're gonna learn. Let's travel to the most extreme place in the universe. What does that look like exactly? Take it away. Wow, I did not mean to do that. Okay, there we go.
The universe is pretty big and very strange.
It is, isn't
Hundreds of billions of galaxies with sextillions of stars and planets, and in the middle of it all, there's Earth with you
That's
and
not
us.
the middle precisely.
But as
though.
enormous as the universe seems looking up, it seems to get even larger when you start looking down. You are towering over worlds within worlds within worlds, each in plain sight and yet hidden from your experience. Let's go on a journey. We'll start in a park about 1,000 meters long, enough for a 15-minute walk. Every time we click this magic button, we'll become 1,000 times smaller. Please slip into this magic science suit so you don't die and can still see. Ready? Let's go.
We got a magic science suit? Okay, so we're in the hypothetical realm. So we're going small.
The miniature realm.
Okay.
You are the size of a grain of sand, just 2 millimeters high, standing on a blade of grass that seems as tall as an 8-story building to you. A square meter of lawn is now a dense metropolitan area with 100,000 blades, or 2 Manhattans worth of grass towers. From your new tiny perspective, the park that you could quickly stroll through before is now the size of France. Crossing it would take at least a week. Human-sized humans loom over you, 4 times
The size of France? Not even
that you
Paris?
could quickly stroll through before is now the size of France.
France?
Crossing it would take at least a week.
Damn.
Human-sized humans loom over you, 4 times taller than the Empire State Building, their
look, my
steps
man.
falling from horizon to horizon. A bee the size of a helicopter lands near you, making the ground shake as its hairy carapace vibrates with each wing beat. You try to escape, but are barely able to move because the air is so gooey.
Gooey.
Before you clicked the button, air resistance was barely noticeable, but as you're now 1,000 times smaller, it's as if the air has become 1,000 times denser. It feels like you're moving through honey. Flying insects like bees use this to their advantage. Their wings are not made for gliding, but like paddles that row through the air. Scaled up to human size, the bee would outrun a Concorde jet, except it couldn't even take off because it would be too heavy for its wings.
Damn.
The microscopic realm. You've
pretty
entered the
fast.
microscopic realm and are now less than 2 micrometers tall, about the size of an E. coli bacteria.
Yeah.
From your new tiny perspective, the park you started in is now 1,000,000 kilometers wide to you. If you walked non-stop, it would take some 25 years to cross it. It's hard to grasp just how huge the microscopic world is to its tiny inhabitants. The giant bee that was close a moment ago is now the size of Mount Everest, towering high into the sky, but alive, humming, and vibrating. The
That's
air
crazy,
here feels
bro.
almost solid to you.
It's crazy how the fabric of reality just keeps going forever. And complexity exists even at the most fundamental miniature levels. Like something exists. But is it just like because it's relative to us that we think of it as smaller, or is it actually just like really, really small? Or is it just because it's small compared to us, so we label it as being small, and therefore we think of it as being small? But, I mean, obviously, like, planets are much bigger in comparison to a bacteria. But it's just like, That's kind of crazy, bro. This shit never ends. The fabric just like it's like an infinite like grid of tiles. Like when you're in like the Desmos for mathematics, like you can just keep zooming in and keep zooming in and keep zooming in and keep zooming in, and it doesn't stop. You can keep doing that forever. You can also zoom out, zoom out, zoom out, zoom out forever. It's like an infinite like scale, you know?
On the human scale,
an
it will be as
infinite
viscous as
plane.
lava, extremely hard to push through. The blade of grass now expands so far you can't see its edges, stretching as wide as Paris would to a regular-sized human. You see valleys that look like dried-up riverbeds, dead patches like deserts, and giant craters left behind by voracious aphids. But if you look closely, this is not terrain. These are rows of individual cells, each the size of a house with hard exteriors like glass shells. Every few cells, there are huge openings called stomata, like mouths, sucking in air and blowing out oxygen. Suddenly, the gigantic bee begins to move. A construct made of rigid pieces that slide against each other like a suit of armor. It takes off to escape a drop of water the size of an asteroid that fell from another blade of grass and is now rushing at you at breathtaking speeds.
A meteor?
You brace for impact, but instead of feeling a strong punch, you just get sucked in. You try to swim, but the water feels thick and sticky and holds onto your limbs like glue. Air molecules are free spirits, while water molecules act more like social creatures that group together whenever possible. They pull on each
Social
other
creatures.
and create a relatively strong
That's us. That's where we come from, water. See how the complexity just keeps increasing and increasing, but it also you can see how it's all made up of the same fundamental parts. Look at that. Likely life began underwater, but near like some hypothermal vent. And what did he just say about the water molecules? He said that they're kind of social. Because, I mean, of course, we make that distinction. We categorize it as such because we're making connections where there probably are none. But
cohesive force
Hey.
that traps you. You can't help it,
Water
but
is
you're still
our
moving,
friend,
tumbling
you know?
in all
We're made
directions,
of water,
helplessly
God,
dragged
so-
along by an invisible current. Floating in this miniature lake are tens of thousands of microorganisms. They take on many forms. Viruses the size of tennis balls float around you aimlessly. Others, like Euglena oxyuris cells, pass you like freight trains. But most look like oily jellyfish the size of a car, sporting long tentacles that act like supercharged propellers. Despite the water holding onto them like glue, some move hundreds of body lengths per second, equivalent to a person shoveling through mud at over 600 kilometers an hour. However, bacteria weigh so little and water is so viscous that they basically have no inertia. There is no gliding on this scale. The result is a weird, jerky motion that's hard to keep track of. Maybe we can learn more about this strange motion if we go even deeper. The molecule realm.
oh shit.
You've become the size of a molecule, just under 2 nanometers wide. At your new tiny scale, the droplet now seems as big as the moon to a regular human. The blade of grass it rests on could reach from the tip of Alaska to the end of Australia, and the park is now almost the size of the solar system. But instead of mostly empty space, it is filled with stuff.
Jesus.
Everywhere you look, there are innumerable amounts of molecules
Imagine
and
being
atoms.
this small.
The rigid walls of the grass cells beneath you are clearly vibrating, rippling with waves of energy. The water droplet contains nearly a sextillion water molecules that are all in motion. Water is actually a storm of H2O molecules smashing into each other hundreds of trillions of times a second. Each of them is moving at speeds of around 2,300 kilometers an hour and bombard their surroundings mercilessly, sending small objects hurtling in all directions. This is the source of the invisible current that you noticed when you were 1,000 times larger. Scaling this speed up to the human scale is impossible, as a human-sized molecule would be 2,000 times faster than the speed of light.
What?
All this furious motion comes from heat. Heat is a bit abstract at our human scale, where you touch something and get a vague sense of whether it's hot or cold. But down here, you really feel what heat is. The motion of molecules, vibrating, twisting and colliding as if they're inside a furious ball pit. When these molecules lose heat, they move more slowly and collide less often. When they gain heat, they speed up and smash together with renewed fervor. Temperature is basically the measure of the average speed of these fantastic dancers performing all day. Suddenly, a molecule hits.
So if a molecule just dances faster to a human, But it's not a molecule. It's like all the molecules together. One molecule's not doing that. But like if all of the molecules are dancing, and they're dancing quicker and faster, and then a human who's however many times, over 1 million times larger than a molecule, whatever, 1 billion, like fuck, but like to that human, it still can put its hand in a pot and feel excruciating pain. Because to us, we feel that it's like, okay, our body's reacting. Oh, stay away from that. That's bad. That's hurting us. This is bad for our system. But it's literally just molecules that are dancing faster. That's really what heat is.
Hits you especially hard,
crazy.
and you're catapulted out of the water droplet into the air again. And here, you see something unexpected. The stuff between the air molecules. Nothing. Between the molecules that make up the air, there is a vacuum. On average, a molecule in the air travels for about 60 nanometers, which is about the length of a hockey rink if it were the size of a human. If we were to compress all the molecules and atoms buzzing around in the room you're watching this in, they would only fill about 0.1% of its volume. 99.9% of the space around you is a vacuum. You just don't notice it. Which also means that every time you take a breath, you breathe in mostly nothing with a few atoms. The subatomic realm. At your size of under 2 picometers, scale starts to lose its meaning. A human would be nearly 2 billion kilometers tall relative to you, so large they could stretch their arms from the Sun to Saturn. An atomic nucleus would be the size of a grain of sand you could hold on the tip of your finger. That grain holds 99.97% of the atom's mass. The rest, a sphere of influence about as large as the Eiffel Tower from your perspective, is filled with an electron cloud. That's basically a stand you could hold Sun to Saturn finger. That grain holds 99.97% of the atom's mass. The rest, a sphere of influence about as large as the Eiffel Tower from your perspective, is filled with an electron cloud. That's basically all the places where electrons might be at any given moment in time. Electrons are shapeshifters that morph around outside a nucleus, creating a new and vibrating mess of different shapes with every new moment. Unlike the graceful motion of planets, the atomic nuclei are chaotic blurs. They bulge, roll, quiver, and breathe. They hold back the same energy that powers nuclear bombs, and it doesn't let them sit still. They twist and vibrate sextillions of times a second. It's time to end our journey.
What are we, bro? What is this? What even is this universe, Brad? It doesn't make sense. We're not built for it. That's why we're just monkeys. Isn't that kind of sad? That we're smart enough to be self-aware of the fact that to be self-aware of our limitations of our knowledge and our ability to come to an understanding of things, because the way that we envision everything, the way that we picture everything, the way that our movie is being played out, the way that we experience the world is through our facticity and like all of these limitations, you know, our cultural backgrounds, our experiences, all of this. None of it is made to understand why an atom moves 6 trillion times. Like, that's not something that we're ever built to do. It's not crucial for survival, and apparently life only cares about avoiding death and not being that closed system. Like, isn't that kind of tough though? Like, okay, you develop consciousness and self-awareness and like really high intelligence to be able to study these things, but you're kind of saddened because you feel like, hey, we might reach a limit in our intelligence. We might never be able to understand this because we're never built to understand this. We're just not. It's probably beyond our capabilities, maybe.
And return to. What you doing? Stop it. The smallest place. We have reached the bottom, the border between reality and unreality. The scale here is the Planck length, which is the distance light travels in a Planck time. Planck time is the time it takes light to travel a Planck length. Okay. None of our models of the universe make sense at scales smaller than this, so for now, this is it. We think that down here, particles bubble into existence and then spontaneously disappear, creating a quantum foam of unimaginable energy. Can we go even smaller? We don't know. It's time to return.
particles burst in and out of existence and create quantum foam. You didn't spend much time there. I want to know more. What about, like, tell me more about this.
If you look up,
foam.
the universe is large and strange. So incredibly large and strange. But if you look down into the tiny and extremely tiny, the universe seems even larger and even stranger. In the end, the perfect place might be where you are right now. Not too big, not too small.
Oh, perfect. That's a big word. But it's like, I think it's equal. I think it's equal. Like, equally, you could get smaller. Equally, you could get bigger. It's not that we're necessarily at a midpoint between those two. Like, you shouldn't imagine like a midpoint, like if we're at that midpoint. But it's like, there's as much out there as there is probably in me right now. So, like, in terms of like how unbelievably, like, there's galaxies in all of us, you know, like, fuck, we get them all.
I'm ready.
We did it. It worked.
Right under our noses, there's so much hidden that we never get to see with our own eyes. Entire realms of bizarre structures and outlandish creatures. What a magical place this is. A forest of slime molds, single-celled organisms that work together and form fungus-like structures. But we don't have time to hang out with these calm fellows any longer. Shh, now we're in the kingdom of the mighty tardigrades. Don't disturb them in their death-like slumber. Don't worry though, they'll wake up once the conditions are less rough. Oh, didn't mean to get in the way. Your cells are hustling to keep you alive, coordinating myriads of proteins. This might be the weirdest place yet, with no up or down. There's way too much going on. Better move on. Now, we're inside one of the parts that allow you to watch this video. The structure of a microchip is so small, it nearly breaks the rules of the quantum realm.
How?
Wait, something's happening.
Then how do you build it?
These hidden worlds are all part of our 12,023 human era calendar.
Of course.
This time, you can
Cheap
join us
blood.
on a journey
I fucking respect it. I might get it.
through the microcosm. With each turn of the page, you will reveal a new world you didn't know existed right beneath your feet. You know the drill by now.
I respect it. Let me know what you guys think. I say equally. Equally both. Damn. SpongeBob reference? Was this SpongeBob?
We don't know. It's time to return.
Oh, did he flip it? Did he flip it?
We don't know. It's time to return.
Yeah, I know the reference. I missed it even watching it again. Fuck, air being 99.9% vacuum? Like space? Like, we think of space as being a vacuum, but is it? Everything they tell you is just a lie, bro. Like, everything that you know is just, like, not true. You end up coming to find out that shit is just not gonna hold up, bro. But let me know what you guys think. I'll talk to you guys next time. I'll see you later. Alright? Take care of yourselves.